All right, here we have you standing on a scale, and the scale isn't moving. Now remember that scales really read normal force. In other words, they're telling you how much the ground is pushing back up. So when the elevator isn't moving, this reads 750 newtons. So that means that your normal force pushing up is 750 newtons. Therefore, because you're not moving up, you're not accelerating up, you're not accelerating down, we know that the forces acting on you have to be balanced. There's only one other force that can really be acting on you in this situation, and that's gravity. So your force of gravity and your normal force are equal to each other, so 750 newtons. You're just standing there. Now you are going to start to accelerate. And the question is asking, what does the new normal force read? Okay, well, actually it's asking what does the scale read, but that's how you interpret it. What is the new normal force? Well, you haven't eaten any tacos, or cut your hair, or changed planets. So your force of gravity is going to be the same, 700 newtons. We need to figure out how much the normal force is going to have to be in order for you to be accelerating up now 1 meter per second squared. How do we do that? Well, there's two things. Whenever we're approaching problems like this where there's a net force, we're going to write two equations. One of them is always going to be the same. F net, which by the way can also be written like this, F net, is equal to the mass times your overall acceleration. That's a great one for the note card. The other equation we're going to write, we're going to have to write by looking at our free body diagram. What sort of forces are involved? Well, we've already talked about this. Normal force is going up, force of gravity is going down. I like to do in these situations the one that's going up minus the one that's going down. So we're going to say, okay, force normal minus force of gravity. Okay. Let's underline the things we know so we can kind of keep track of them at this point. So far in these equations, we don't know the mass. We do know the acceleration. We do know the force of gravity, and our overall goal is to get this normal force. Well, the thing holding us back from getting the normal force is the net force there. So if we can figure that out, we're golden. How can we find the net force? Well, look at this equation up here. If we want to get the net force, the only thing that's really stopping us is getting the mass. So let's go after that mass. Let's see what we can do there. They didn't give us the mass, but you shouldn't worry. If you ever know the force of gravity and you're on Earth, you know the mass. So the equation that's going to help us with that always is Fg is equal to mg. Remember, g on Earth is always 9.8. So we have 700 equals our mass, and g again is 9.8. So our mass, when we divide 700 by 9.8, is 71 kilograms. All right, so now we know, we can take that, we can kind of think about, we know the mass now. If we know mass and we know the acceleration, we can find the net force. So we can go F net is equal to mass times acceleration. F net is equal to 71, and our acceleration is 1, so we're having a net force of 71 newtons. So that's pretty useful because we needed net force in this equation in order to solve for normal force. So we can now say, all right, F net was equal to our force normal minus our force of gravity. So our net force was 71. We don't know our normal force, that's what we're looking for, minus force of gravity they gave us, which is 700. I don't know why they put that in parentheses, it's early. So we can add 700 to the other side. Running out of room. We get 771 newtons is our normal force, and that is what the scale would read.